And at the top of page 574, we're going to give this title, Add to our notes. And these questions can be asked in a number of different ways. Sometimes they say, provide the general solution, which means every single answer. Sometimes they'll give us the domain. As theta belongs to all real numbers. And sometimes I've seen on the final exam, they just say solve. And if they don't say a domain, they assume that you mean find every single answer possible. Lately, the exams have been better at saying find the general solution or solve for theta where theta can belong to all real numbers to be more specific. So there's two basic steps when you have a general solution. One, you're going to find all your answers from 0 to 2 pi, just like we did in the previous 4 examples. So you're going to solve basically what we did before, where we figured things out between 0 and 2 pi. Then if you have all of your answers between 0 and 2 pi, then in order to do the coterminal thing, like we did before, you are going to add 2 pi k or 2k pi. Doesn't matter where you put the k, where k is an integer to each answer. So then at the bottom of page 574, you can write omit over the example that they've done, and we're going to solve this one instead. So solve for theta where theta belongs to all real numbers of 7 sine theta plus 1 equals 0. Yes? You could also solve it between 0 and 1 period. I find that solving it between 0 and 2 pi and adding 2k pi gives us a method that will work whether or not the period's been changed or not. And it seems to be easier to understand. Right, but then what you add each time is a fraction of the period, which can be confusing. Okay, so solving for this one, you're going to get sine of theta is negative 1/7. That's not on our pi plate, so this is a calculator question. Since sine is negative, thinking to our cast rule, we know that it's going to be in quadrant 3 and quadrant 4. If you want to draw a picture of what's happening, you know, opposite side is 1, adjacent side, hypotenuse is 7, and here would be our reference angle. Now again, once you get better at these, you won't have to draw your reference angle over and over again. However, drawing your reference angle is a nice reminder that we use positive values for finding it. So when we do sine inverse of 1/7, we get 0.143. As our reference angle. I'm going to store that value as x, so I can find pi plus my reference angle one answer for will be approximately 3.28, and 2 pi minus my reference angle 6.13. 14. Now those are my answers from 0 to 2 pi. To write my solution now, what I'm going to do to each of my answers, and since we have multiple answers, I'm going to add a squiggle bracket here. I'm going to take 3.28 and add 2k pi. I'm going to take 6.14 and add 2k pi. And I'm going to say that k belongs to the integers. So this would be my final solution to provide the general solution. I take the answers from 0 to 2 pi like I did before, and I just add 2k pi to each of them and state where k is an integer. If you wanted to, you could put a comma in k-ez for each one. This straight line in k-ez means that it applies to both of them. Yes? Yes, and if it was degrees, you do plus k times 360 or 360k and still have k as an integer. So angles in radians, 2k pi, angles in degrees, 360. And all you're doing is saying, these are the answers I found, and I'm also listing every single coterminal one that goes with it. So it's connected to what we did before when you're finding coterminal angles.